Alright, so we're going to start off today talking about iOS firewall, as well as miscellaneous access lists and other types of options as well. So starting off, basic general information, looking at access lists in general, standard access list, extended access list, standard access list just matching on source address, extended list, being able to match on a lot of additional items. So getting in deeper, looking at specific protocols, source address and destination address, specific protocol options, ports, type codes, as well as individual packet markings for the TOS bits, DSCP, IC precedence, those sorts of things. So getting into more items available in the extended access lists, a lot more features and functionality, being able to be a lot more specific instead of just looking at source information. Access lists in general, different things to do with an access list. Looking at access lists themselves, looking at the counters can be very beneficial. And look at that information with the console, monitor, buffer, syslog, anywhere that you are doing logging. It'll be done with the log options. The different information that you receive back when you're logging those, you can log either permits or denies. What the list name is or list number, what the permit or deny was, what traffic was seen, what was the protocol name number, the source or destination address, and what port numbers were seen for that particular traffic that was either permitted or blocked. In addition, we also have the log input option. The log input option takes all those options, but also has additional information, either the source layer 2 address with the either MAC address or input VC. So what sort of situations might I want to use a log input over a log option? Quiet group this morning. So times when you might want to use the log input option, one of those would be if you want to possibly try and trace down the source of an attack. If I have, say, an Ethernet subnet, just because I have the source address, that doesn't necessarily help me if I have other hops leaving that subnets. Looking at the layer 2 information, the MAC address info, then I can see where that's coming from. If I have a switch network, I could see from there which switch port that MAC address was learned on, where that traffic was coming in. So being able to get into additional information trying to track down attackers, track down malicious traffic coming into my network. Now, we say that we can do this logging, and we can do it to anywhere we have the syslog set up, console, monitor, buffer. Syslog itself has a variety of message levels. Do you ever know what message level you need to have to be able to see log options on the syslog messages? For the syslog messages, it does need to be logging at level 6 or level 7, because that is the level where those messages are coming in at. Make sure that if you are trying to look at things, you do have your logging set to a high enough level that you are able to catch that information. Applying access lists. Different places access lists themselves get applied. Can be used for general traffic filters, IP access group on the interface, access class for the VTY control, what you're allowing inbound or outbound for the exec access on particular VTY lines. Also commonly used in things like route filters, can also be used in things like MQC policies, being able to match certain traffic types. Additional features available with the extended access list are time-based options. So being able to add in a time range, have a time range defined, and then with that time range defined, able to specify either as an absolute at a certain time or possibly something that's recurring. It's possible you may have a policy that you may be allowing certain traffic during weekdays and allowing other traffic on the weekend. So depending on what your business environment is, you may have different needs at different times of day, possibly different policies on specific days as well. Time-based ACLs allowing you to do that. So you define a time range, give it a name, and then in your extended ACL, able to correlate to that and match up with that time range value. Now, going beyond just a basic access list and having access list, time range being slightly dynamic, where you do have things changing, in this case, changing at a certain time. Other dynamic ACLs, one example of that would be the lock and key ACL. So I have an ACL that's on a device that's restricting access and forcing someone to authenticate on that device before I'm going to allow them to pass traffic through. So in this case, different possible applications. It could be from inside to outside, possibly if inside going out, forcing a user to authenticate before they're sending traffic on to a server or to the internet. Traffic coming from the outside, possibly if you had an internal server you're protecting, forcing the user to authenticate first before they access those resources. So different possible directions. Again, look carefully at what you're asked to do. Different options for configuration can be used with a explicit permit or the implicit deny. Starting off looking at the first option, with the explicit permit, say I have my web server that I want to protect. I have a dynamic permit statement for that web server, a static deny statement, and then a explicit permit statement to allow other traffic that's not to that web server. In this case, my static deny statement would be blocking traffic to the web server. However, that would be overridden by the dynamic permit because the dynamic permit has a entry that's closer to the top for the access list. In this case, when the dynamic entry is activated, then the user would be able to connect to those resources. When the dynamic value timed out, then it would revert to being affected by the static deny statement there. And then the explicit permit to allow other traffic. The second option, using the implicit deny. In this case, if I want to generally restrict most traffic, having a dynamic permit, but then having any other traffic just using the implicit deny that's at the end of an access list. So the implicit deny any that falls at the end of the access list to block other traffic. Configuring dynamic ACLs, configuring for lock and key. So in this case, you start off within the access list itself, somewhere you have a dynamic entry. In this case, a dynamic entry named Bob as an entry within access list 100. Again, the order of where that item is in the access list does become important. You need to make sure that that item is above the deny for the corresponding item. I have seen a lot of people that have their dynamic entry at the bottom of their access list and don't understand why it's not working. And they try to connect, and it adds the entry to the access list, but because that entry's at the bottom, it doesn't actually do anything. Now, with the dynamic ACL, the access itself is not automatic. In this case, it's done with the auto command. The auto command using the access enable keyword. Access enable is a global command that can be used to open up the dynamic ACLs that are applied to interfaces. So in this case, you have an ACL on an interface. We have the auto command being run so that the user does not need to know any commands. They just log in, and after that user logs in, it kicks off that command. Now, as far as how that's done, that can be done user-based. In the first example here, username password with the auto command tied to that username, and it can also be line-based. So I can just do auto command on the VTY line itself. Does anyone see any problems with doing the auto command on the VTY line itself? Some of the problems that can arise with it being on the VTY line itself is that you then lose the ability to manage the device. If I have something tying up my VTY line 0 to 4, and I then want to be able to telnet or SSH to that device for management access, I'm unable to do that on those VTY lines. And because those VTY lines are tied up sequentially in order, I would have to have 5 sessions open before I could connect and manage the device. So other possible items, you could get into something like using a rotary and having it bound to a higher numbered port, or possibly connecting for management on a higher port. Other questions on authorization. Depending on how things are set up, you may or may not need the authorization, depending if you're doing just local setup or if you're using AAA. And we're going to look at an example here with just a local login authentication here as well. Again, make sure you have your access list applied as well to your interface. So we're going to look at a dynamic ACL example saying that someone wants to first authenticate to router 1 before accessing a private server. In case assuming router 4 is a private server, router 1 is going to be the device we are authenticating against. Go ahead and bring up our telnet window. Now in this case, router 1 is where we're going to be configuring the information itself, where we're configuring the dynamic ACL. Go ahead and just set up an ACL on router 1. Now initially we want to have access to the device. In this case, we're just blocking connections to router 4. So we're going to start off with our dynamic entry. And in this case, we're going to look at it being towards the loopback of router 4. And in this case, we're also just going to do a permit IP any. Wanted to lock down to a specific TCP UDP port. We could do that. In this case, we're just going to look at a general example permitting any traffic to that host. Now that's a dynamic entry, so that's not always going to be active. And then we're going to have a deny statement. And then the permit statement for other traffic. Now we're going to go ahead and apply this to the interface. So we're going to take a look at our interface here. Be on our serial 00.12 interface. And go ahead and apply that on the inbound direction. Verify from router 1 that we can ping that loopback address. And we're going to check from router 2. And from router 2, we should not be able to ping that address. Are getting unreachable here. Turn on our debug, and we can see what we're getting for that unreachable. Case administrator prohibited, unreachable from router 1. We can show our traffic being blocked. And hit a question here on the PDF. Are you not able to access the file, or is that one just not coming up? Got it all set? Okay. So in this case, at this point, we're currently being blocked. We take a look at our access list on router 1. We do see some counters there on that deny, for that deny traffic. We do see our dynamic entry on our access list. Next, we want to have a device authenticate before accessing the private web server. So just looking at it now, at this point, we do not have the auto command on there. We're just going to try and connect from router 3. Get a destination unreachable. Should get the same thing with the ping getting the unreachable to that device. And we go ahead and log in against router 1. So logging into router 1, in this case, just a telnet connection, could be via the serial interface, could be connecting to the loopback. Into enable mode. Now, as mentioned, the access enable was a global command. In this case, we don't have an auto command. We're just going to go ahead and run the access enable command. Now if we look at our access list, so under our dynamic entry, we now have a separate line that's an active entry that would permit traffic. So if we exit this connection here, prior connection just from router 3 here, pinging to router 4, or telnetting to router 4, we can now establish that connection. So we tested the basic functionality, saw that it put in the entry for the dynamic access list. Next, we're going to go ahead and adjust things slightly here. Looking at our access list, have that entry. We're going to go ahead and clear that out. And our dynamic list name is test. And we're going to go with any. Cleared our template there. Look at our access list again, and we've cleared out that dynamic entry that was there. Now, one of the things that you may have noticed on the dynamic entry, it did just have the permit IP any to that destination host. There was a note on the previous slide. If we jump back here for just a second, previous slide, we do have a note here at the bottom that there is the host option. The host option will just open for the authenticator. So if I have multiple people there, in this case, not opening up for anyone, just opening up for the particular person that did the authentication. In this case, we're going to look at the settings here. We're going to go ahead and adjust that. In this case, we're going to go ahead and just add in a user on router 1. Username Cisco and a password of Cisco. We're also going to give that username an auto command. Access enable host. I'm going to do a separate username here. We have administrative access. Username admin, password admin. And we're going to take our VTY line and set it for login local. Now on newer versions, you do have a lot more options for VTY lines. Looking at my VTY line options on this particular device, generally does vary by version and platform. This particular one having 181 for my last line number. So be careful if the section says that it should be affecting all VTY lines or certain VTY lines, that you do check that to be sure. It does start at 0, so if I say the first 5 VTY lines would be 0 to 4, the first 10 would be 0 to 9. So I've got my username there, auto command access enable host, login local set for my VTY, and the username admin, password admin. Go ahead and switch back to router 3. And if I try my telnet again, telnetting directly to router 4 should fail because I did have the dynamic entry removed. In case I do get the destination unreachable, go ahead and connect to router 1. Name Cisco, password of Cisco. Now what we saw there, my connection was closed. So I'm going to go ahead and try my telnet again. The auto command will run the command, but then it will also kick you out. So be aware of that. So we can see I can now access my device. I can now access through to router 4. My lock and key is working. Exiting my connection back out. Take a switch look over at router 1. And again, we now see we have a dynamic entry back in there. And also this time, slightly different in the dynamic entry does show the host that did the authenticating. In this case, that particular host that authenticated is the one that is seen for that traffic. So it's not just allowing anyone to connect to that. Okay, so we had it done with a username with an auto command. In case we're going to test from router 3 as well. Verify that we can still connect to our other device. And we did have a separate admin username there. And our admin username password is still able to manage the device on router 1. Whereas if we just had it on the VTY line as the auto command, would not be able to get into that for management access. Now the other option we mentioned as far as moving things around was the ability to use a rotary. So we can take a rotary. We'll just take a higher VTY line. Rotary allowing the device to listen on a higher numbered port. So for telnet, adding 3000 or 7000 to the number. So rather than listening on port 23, if I do a rotary of 5, I'm now listening on 3005 and 7005 in addition for telnet there. Say login local. Go ahead and remove it off the other VTY lines. Back to router 3. Try to connect to that device. In this case, we did take the login off of the lower VTY line, so it is just putting us directly onto the device. We try telnetting on the higher numbered port that we opened up for the rotary. That rotary line is looking for local, and we can do the Cisco. In this case, it did try and kick off the authentication. It did already have us listed as an address in the address pair, so it does give us a little error message there. Did clear that template out, just showing how you can use a rotary to shuffle things around to a separate location. Any questions on lock and key? There was one question earlier on the DDR. The other slide did mention time-based ACLs for DDR. DDR, again, not in the actual lab exam, just given as an example of when you might have a time range set up. So depending on what your particular circuit requirements were, Some circuits may have different times of day that they have different pricing schemes, so may not want to dial during certain times of day if not needed. So just additional options there, not something to be worried about for the scope of the security lab at this point. Another question, typical weight of iOS features in the lab. It really can vary. iOS features themselves could be in the separate section themselves. It could be something that's building on to an existing item. So it really depends. Beyond that, it can be other things configured for testing. Something like a DHCP server can be fairly straightforward to add in and set up for the testing of something if you're doing something for DHCP or say DHCP snooping. Generally not a whole lot for general iOS features themselves in the lab. As far as other general categories, access lists, lock and key, reflexive iOS firewall, depending on how things look at, that can be looked at either traffic filtering or getting into the firewall sections themselves. Generally not a whole lot there as far as points go, but still something that can be critical if it's not set up properly. So moving on past the lock and key ACLs, we'll talk a little bit more on the AAA side later on. Those can also be done just authenticating against the AAA server. We can also get into things like cut through, having the ACL information pushed down from the AAA server. But we'll talk about that a little bit later in the week. Other things to be aware of in general with lock and key. One thing to be very careful of with your access list construction is making sure you're still allowing that initial connections through to the device. So in this case, my connection to router 1 had the ACL on it. Looking at the diagram here, router 1 having an ACL on his serial interface. Because you have an inbound ACL on the interface, in this case, you really want to make sure you're just blocking the traffic to router 4. If you just had a deny statement at the beginning of that access list, you could potentially block routing protocol traffic, other traffic coming into router 1, and possibly even the authenticating traffic. So all that traffic needs to be there. Your general routing protocol shouldn't be affected between, say, router 1 and router 2. General authentication traffic, router 1 needs to be able to telnet access on that port from, say, router 3 for the authentication. So make sure that you're careful with that access list construction. For the most part, access lists should be basic and straightforward, but I've seen a lot of them misconfigured and cause people a lot of headaches just because they're not looking at what they're actually permitting or denying in their access list. So moving on, the reflexive ACL, the earlier looking at stateful firewall inspection. So the earlier attempts at stateful inspection, generally a subset of the newer functionality on the devices, security devices, ASA, as well as what CBAC can do now. Generally just watching the traffic leaving, permitting traffic back in based on state information. Now with the reflexive access list itself, looking just at general state information, okay, I saw traffic leave on this port, I'll allow traffic back on that port. So not as deep inspection as CBAC itself, and we'll talk about in a little bit, getting into other application type things. In this case, basically just looking at port information on the devices. So two different parts, in this case having two separate access lists configured for the reflexive, have one outbound and one inbound. So on the outbound, doing reflection, in this case the example having TCP, UDP, and ICMP traffic. With the reflect statements configured, he's looking at that information and putting that into an internal table for what those connections are. Now on the inbound traffic, having the evaluate statement to allow those items that it sees that it saw leaving the network, allowing those coming back, and then beyond that, a deny statement for other traffic. Now, in this case, that is not a complete list for the inbound ACL. Again, other things that could get blocked, other routing protocol traffic to the device, other connections through to your end device, situations like that, those things would need to have other permits. The key being the evaluate is going to match to items that were reflected in the other direction. Now, in this case, looking at TCP, UDP, and ICMP, you do not have to watch all three of those. You could just be watching the TCP traffic or just the UDP traffic or possibly just the ICMP traffic and have other explicit permits on the inbound side for the inbound ACL. Other things to be aware of. As far as the outbound access lists go, generally not going to match locally generated traffic. So anything locally terminating on the device would still need that traffic to be permitted back in. So things like routing protocols on the interface, echo reply, trace route, responses back. Some cases you can get around it with local policy routing. You can do policy routing, have it configured with the route map to send traffic off of a local loopback, and then with that, it will catch in the outbound access list. However, it's not 100%, and some types of traffic it will work, other types of traffic it doesn't work very well for. So some things like ping, it may work okay for. It may catch it going out, allow that reply come back. Something like telnet, the way the session is and the way it terminates on the device may not handle that properly. We're going to look at a reflexive ACL example here. Similarly to router 1, in this case saying TCP, UDP, and ICMP traffic should only be allowed in router 1's free relay connection if it was initiated from router 4. So in this case, we're going to jump back to our device here. And on router 1, we're going to take off our access list. And we're going to go ahead and create our two access lists. So we're going to start looking at traffic outbound. Allow the traffic out. UDP, and we said ICMP. And we're going to create a separate access list. 102. And we want to match our reflections. We're going to take a look at those. Now, in addition, as mentioned, I do need to have potentially other permits. My section itself just said TCP, UDP, and ICMP traffic. So looking at my section requirements, TCP, UDP, and ICMP traffic should only be allowed if it was initiated from router 4. In this case, I'm going to permit other traffic. I'm going to put in some denies here. I'm going to deny for TCP, deny UDP, and deny ICMP. And then I'm going to do a permit IP, and just generally allowing any other IP traffic. Now, as far as clarification from the proctor, in this case, it does say should only be allowed if it was initiated from R4. You may want to get clarification if it means that it has to physically be originated by router 4, or if it's just anything coming through the device in this direction. So if it specifically meant anything initiated from R4, you may want to get clarification, possibly restricting those reflect statements to just look at traffic with a source of one of router 4's addresses, either loopback or the interface. Or if it's sufficient just to catch things in that direction, then you just have it as we have here with the any for the source. Next, we're going to go to our interface and go ahead and apply these access groups. Now we have access lists on our interface. Generally, anytime you do that, you want to watch very carefully. You may want to have things like, as mentioned earlier, a deny with the log at the end. In case we have a permit there, so we shouldn't be blocking anything. You could put logs on your denies. It's going to check, verify that our neighbor relationships are still up. Okay, so still showing a neighbor relationship to router 4 here. Go ahead and verify. Notice that our dead time did increase. So we did get a hello in that time frame. Default for networks there being different for timer values. We are still getting OSPF traffic in our interface. We could also debug the traffic itself. Going to go ahead and take a look at trying to ping. In this case, we're not allowing ping. So in this case, we would not be able to ping from router 1 itself because of that traffic being blocked by the inbound ACL. Again, you may want to ask if you need to still allow access to the device itself or ping traffic to router 1 itself. In this case, the section itself stated only if it came from router 4. We're going to switch over to router 4. Verify that we can ping from there. And we do have a ping response there. So we can see the session passing through and the return traffic being allowed. Also should be able to telnet from router 4. Able to telnet through to that device. And we try from router 2. Router 2 trying to connect through to router 4. In this case, getting the unreachable back from router 1. Any questions on reflexive ACLs? All right, so we're going to move on and set up our next section here. So we looked at lock and key. Lock and key being able to dynamically have access to a device, dynamically connecting to a device, having entries added to access lists. Again, a little bit cumbersome there. Reflexive access lists, looking at the earlier attempts at watching state, so looking at basic state information for the devices. Next feature we have is TCP intercept. So TCP intercept, looking at preventing SYN denial of service attacks, generally something like a web server, looking at the number of half-open TCP sessions, looking at information, watch mode or intercept mode. So watch mode, just looking at the connections, what connections are being established to the device. Intercept mode, the router device in the middle physically proxying that three-way handshake and not sending those SYNs onto the end server or end device unless it's getting response back from the initiator. General problems with TCP intercept, for the most part in modern environments, for the most part, servers are generally able to handle a decent number of connections. So offloading the attack to your router having to proxy all those could be problematic in this case. If the router physically proxying all those connections, watch mode can still be good to block connections, but for the most part, probably not wanting to push all that traffic off to the device. So we'll take a quick look at TCP intercept a little bit later. Now we're going to go ahead and take a short break and then jump into the CBAC or iOS firewall.